In the last section, we had a very long discussion about what Kubernetes is doing behind the scenes to deploy our application with some given deployment file. And there's a couple of takeaways I want to highlight very quickly. So here's a couple of important notes that I just want to kind of double down on and make sure are really clear. So first off, Kubernetes overall is a system to deploy containerized apps. We've been talking about services and pods and objects and all this stuff, but at its core, it's all about deploying containerized applications. Some of these different objects that we're going to make use of have a goal of supporting these containerized applications, but at the end of the day, it's all about running containers. Next up, a node is an individual machine, like a physical computer or a virtual machine that is going to run some number of containers or objects. On your computer with Minikube, you are currently running exactly one VM that is behaving as the node. We also have a master. This is a machine or virtual machine that has that set of programs that are going to be managing everything that goes on inside the nodes associated with your Kubernetes cluster. Now, the next item on here is something we didn't quite cover. Remember Kubernetes, we did. We spoke about Docker Hub. So Kubernetes specifically did not build our image. It got the image that we wanted to deploy from Docker Hub. Next big thing is that the master decided where to run each container. You and I did not add in any input saying, hey, specifically, I want you to run this multi-worker container like over here or over here. Now, we absolutely can control where a container gets deployed. We can add in some configuration to our deployment files to say, oh yeah, I want this pod that gets created to be created on like this node or this node. We have the ability to do that, but by default, the master is going to decide where to deploy all of our different objects for us. Now, the last two items on here, and this is the real focus of what I want to cover inside this section, is this is the important stuff. So to deploy something, we updated the desired state of the master with a config file, right? We passed in this deployment file over here, and the master updated its little list of responsibilities to say, oh, okay, yeah, I understand. I'm supposed to be running 4 copies of the multi-worker image. So the way in which we interacted with our entire Kubernetes cluster was to update its desired state. We said, this is what we want you to be doing. We did not specifically say something like, hey, please create this copy of multi-worker, and this copy, and this copy, and this copy. Instead, we just very generically say things like, I want to run 4 copies. And then we hand that directive off to the master. And the master is in charge of making that happen. Now, the other big important thing here is to understand that the master is going to work constantly to meet your desired state. And that was the entire purpose of me killing one of those containers and showing you that Kubernetes automatically restarted it for us. So the master is going to just constantly churn away at its list of responsibilities and make sure that our desired state right here, like the fact that we need to have 4 copies, is always going to be met. Now, again, this entire topic, or this entire idea of having the master kind of work to meet our desired state, and the entire idea of us passing some desired state to the master in the form of a configuration file is really key to understanding Kubernetes and how you and I work with it as a developer. So we're going to look at a couple more diagrams that are going to expand upon this idea of us kind of telling Kubernetes what we want, as opposed to us very specifically saying like, hey, please create this pod or something like that. Now, this overall topic is kind of a discussion between 2 ways of approaching deployment. We could approach deployment with an imperative style or a declarative style. With an imperative style, you and I would issue a series of commands that say specifically like, create this container, and create this container, and then delete that one, and then upgrade that one, and restart that one, or whatever might need to happen. In the case of a declarative deployment, we say to our master something like, you know, it'd be great if you just made 4 containers happen and made 4 containers happen all the time. And you know what, master, you just go ahead, you figure out how to deal with that. So with the imperative, we give very discrete actions, or excuse me, very discrete commands. With the declarative, we kind of set guidance or a directive. We say, just make this happen for me, would you please? Now, just kind of giving you a quick overview right there is not really enough. So I just want to show you a couple diagrams to really drill home the point or the differences between a imperative deployment and a declarative. Okay, so here's an example of a imperative deployment. I want you to imagine for a second that we did not have access to any of these configuration files or anything like that. And I want you to imagine that we just had access to some like imaginary Kubernetes command line. All right. So I want you to imagine that you and I have or need to have 3 containers. Like for whatever reason, we decide that our application has to have 3 containers right now. And let's imagine that we don't really have any Kubernetes commands or anything like that to get the current status of how many containers we are running. So what would you have to do to make sure that you have 3 containers? Well, chances are you would have to open up some dashboard on Google Cloud or AWS, and you would have to look at the overall state of your application. So maybe when you open up your dashboard, you see that you have 4 containers running. So what would you have to do to get 3 containers? You would have to very distinctly look at your current state and then figure out some way to migrate from your current state of 4 containers down to 1 container. And so you would have to just say, there we go, fix that up really quickly. You would have to issue some command to say, okay, I need to remove 1 container to get from having 4 down to 3. And so you might issue this imaginary command that says something like, Kubernetes remove 1 container. Now, the important thing that I want to really drill home here, this is the really important thing to understand, is that even though it kind of seems trivial to say, okay, I need 3 containers and I currently have 4, all I need to do is remove 1, that still required a lot of computation out of you. You had to understand your desired state. So your desired state was to have 3 containers. You had to do some research to determine your current state, like how many containers you currently have, and then you had to come up with some migration path, some series of actions that would take you from your from your current state to your desired state. And so you would have to come up with this migration plan that says, okay, I'm going to remove 1 container, and that will take me from my current state to my desired state of 3 containers. Now, I'm sure that sounds like a trivial example, like, Stephen, really? Figuring out to remove 1 container is hard? Well, let's look at a more complex example, all right? Slightly more complex. So in this example of an imperative deployment, let's imagine for a second that you have a ton of different containers running, and they're all running some very specific version of the multi-worker image, like maybe version 1. And so you come along and you decide, all right, I need to update every running container to use image version 1.23 instead. Now, in this case, things would be a lot more challenging. You would have to open up your dashboard. You would have to find all of the different containers that were running the multi-worker image. So for example, maybe like, this container and this container and this container right here, maybe these were running a completely different image. And you want to update this one, this one, this one, this one, and this one. So maybe you would want to update the versions used by the green one. So now, determining a migration strategy is a little bit more complicated. You have a desired state of running version 1.23 inside of every container. You have a current state where these container are running maybe version 1 or whatever it might be. And so you would have to figure out some way of isolating just these green containers and saying, okay, I want to pick out like container 1, 2, 3, 7, 20 right here, and I want to update just those. And so you would have to figure out some series of update actions to just update that very specific set of containers. And again, I'm going to argue that that might be really challenging for you to do. So how would we approach a problem like this with a declarative deployment rather than an imperative deployment? Another diagram. So this is how we would do things with a declarative deployment. You would say, okay, I need to update all of my containers running multi-worker to version 1.23. So here's what you would do with Kubernetes in an ideal world. You would open up your config file. So like this config file right here, the same one that we just put together a little bit ago. You would find the image designation right here. And you would update the tag on this thing to say, I specifically want to use version 1.23. You would then save that file, and then you would say send that config file off to Kubernetes. Master would then inspect that file. It would update its own little list of responsibilities right here and say, oh, okay, I understand. I need to be running version 1.2, 1.2.3, or whatever it might be.
And then the master is going to automatically find all the nodes that are not running version 1.23. It's going to take those all down. Excuse me, not nodes, but pods. It's going to take all the pods that are not running version 1.23 down, and it's going to create new pods that are running the correct version. And now my question to you is, which of these two deployment processes would you want to go through? Where's my diagram? Over here. I bet you would probably want to use this declarative process. I bet anything you would not want to be responsible for looking at the current state of your cluster, finding all the outdated containers, and writing a command to update each of them. Instead, it would be far easier to just update a single config file, send that config file to Kubernetes and say, here you go, take care of it. Like, I don't care. It's up to you. Figure it out. And Kubernetes, the master, is going to constantly work to make sure that its configuration is met and make sure that whatever the real state of the nodes are is what it needs to be. Okay, so this has been a pretty long discussion, and I think that you probably get the idea now of the differences between a imperative deployment and a declarative deployment. So why am I telling you all this, right? This has been like 10 minutes, so I'm really drilling in here. This has been a very in-depth talk. So the reason I'm telling you all this is that when you start looking at Kubernetes documentation, blog posts, Stack Overflow posts, whatever else, you are going to see some resources out there recommend that you take a imperative approach. You're going to see some resources that say, oh yeah, write in a command into kubectl that specifically adds a pod, or specifically removes a pod, or specifically updates a pod, whatever it might be. But I'm going to tell you that Kubernetes has the ability to do things both ways. So Kubernetes has the set of commands through kubectl to take this imperative approach. That is the set of commands that some blog posts out there are going to advocate. And they're going to say, oh yeah, run something like pod, update, whatever it might be. But Kubernetes, or kubectl, also has a set of commands to do things through a declarative approach as well. Throughout this course, you and I are going to constantly strive to only use the set of commands that take a declarative approach to building out a Kubernetes cluster. That's the whole point. That's what I'm trying to convey here in this entire lecture. I want you to understand that when you start reading these blog posts, some of them are going to tell you to do things in an imperative way, but for any real production deployment, every engineer out there, everyone in the community is always going to advocate taking the declarative approach. That's the entire point of Kubernetes. And so it's going to be kind of up to you when you're reading a blog post to understand that, okay, maybe not all these blog posts are saying things that are 100% accurate. And hopefully, eventually you'll start to develop a sense of when a blog post says like, oh yeah, just go run this command to update this pod in place. That's probably something you don't want to do. In general, you and I are going to always try to do the same thing over and over and over again of updating a configuration file and then sending that config file off to Kubernetes master again and again and again. And so throughout this entire course, everything that you and I are going to do from here to the very end is going to be all about updating these configuration files with some new desired state, and then eventually sending that off to Kubernetes master. And we're just going to repeat that process over and over and over. And that's exactly how you are going to do things on your own application. And that's how you're going to do things, especially in a production environment as well. All right, so that's enough soapboxing for me for a while. So let's take a quick pause right now. Now that we've gotten all that out of the way, we'll take a quick pause right now, and we're going to continue in the next section. So quick break, and I'll see you in just a minute.